Let's do an example, and then let's see what the pattern is. You with me? So what we're going to do is we're going to factor y squared minus 9. Okay, so this is a quadratic, isn't it?
Yeah.
And with quadratics, you can factor them using the AC method. And so what's funny about this is basically you're missing the b term, right?
Mm-hmm.
There's no b term. But your AC would be what? Careful. -9, wouldn't it? And now what's interesting is you're going to think of what numbers multiply together to make -9, but add together to make the middle term. But what did we say the middle term essentially is? If it's gone. It's going to have to be 0. So what two numbers multiply together to make -9, add together to make 0?
3 and -3.
3 and -3. So this is kind of strange because we're missing a middle term, but now we're splitting up the middle term. Isn't that weird? So here's how you'd write this. You'd go y squared plus 3y minus 3y minus 9. Do you guys agree that if you simplified this, you would get this?
Yeah.
Isn't that weird? And then what you do is you go plus a negative and you group it. Make sure the plus sign's in between. What do these have in common? What do these have in common?
3.
-3. Divide. Finally, our answer, when we factor out the common binomial, is y plus 3 times y minus 3. Whew. All right, we made it. Well, there's actually a pattern you can use to go from here directly to here. Okay. But you probably, with one example, there's probably not enough to get the pattern down. So let me show you some other ones. Let me show you here. Oh, this is a good one. Oh, okay, this will be fun. Okay, 4c squared minus 1. I guess we'll go ahead and do the AC method again. It'll be kind of fun, I guess. What's our AC? -4. What two numbers multiply together to make -4 but add together make 0? -2. 2. Split up the middle term. Make them C's. Factor by grouping. What do you factor out here? A 2C. What does that leave behind? 2C minus 1, I think, right? Back here, can you factor anything out?
-2.
But so we do a 1, don't we? And now factor out this common binomial. We get 2C minus 1. And what's left over? 2C plus 1. All right. Okay, so take a look at this and this. Okay, take a look. And take a look at this and this. And try to see if there's a pattern that you can discern. What do you see, Lexi?
Couldn't you divide the first thing by 2, whatever squared, divide that by 2 and then put the factors in with it? The AC,
Kinda. We're not actually dividing it by 2 though.
Something similar to square root.
or separating?
Yeah, we're actually square rooting them. Square rooting them. So I think what you kind of meant like y squared. Did you mean when you wrote y, that's kind of like dividing it by 2?
Yeah.
But it's not. What it's doing is it's actually, you're taking y squared, and what's the square root of y squared? Well, square root would undo the squaring, right?
Mm-hmm.
And you get y. Write it in both places. And then what's the square root of 9? 3. And then,
You square root it?
yeah, let's try that out on this one. What's the square root of 1? 1. What's the square root of 4c squared? 2c. And then look at the signs. It's always what?
Negative and positive.
1 plus, 1 minus. Okay, so let me do one more. But this time, I'm not going to make you work it out the whole way. I'm just going to tell you what the answer is to really drive home the pattern. Take a look at this. If you're going to do the AC method, this would take a while, wouldn't it?
Mm-hmm.
You're going to have big numbers, aren't you? And you're going to have the extra y going on, right? Which we found out really isn't a big deal, is it? But what's funny is when you split up your middle term, you'd have to have an x and a y. XY, XY. It would be really strange to do this. But it turns out if you know the pattern, you're going to go straight to the answer. You're going to say, oh, that's going to be 7x. That's going to be 9y, and the pattern always goes 1 positive, 1 negative. And you'll be done super quick. So what this pattern is, how we're going from here to here, is this is called a difference. I don't think they can see that. It's called the difference of 2 squares pattern. Difference of 2 squares. And it goes like this. If you see that you have a perfect square, subtracting from another perfect square, it's going to always split up into the square roots of them. One plus, 1 minus. And that's the way it'll always work out. Difference of 2 squares. Cool. Yeah, that's it. Yeah. You guys want to do the pattern? Well, we got one other pattern to do too. You guys want to do one real quick? Okay, let's do another one. Oh, I'll come around and check you. All right, let's do. Make it a little complicated, maybe. 225x squared minus 9. Factor that. Oh, and actually, hold on. Time out. Tweet. Do something a little different. And the reason why is I didn't really want you to factor out a monomial first. So try this one. You might need your calculator to see what's going on, right?
Oh,
Raise your hand when you think you've got it factored. Oh yeah. Uh-huh. Yes, indeed. Oh, yeah. I'll go you to the hoodie. It's a classic. Yeah. Nice. Difference of two squares. Delightful. Delightful. Now, I probably haven't stressed enough how helpful this is. If you were going to do this problem with the AC method, you'd be in for a bit of a chore. Are you guys with me on that? Think about what your AC would be.
Big.
It'd be a big old number, wouldn't it? It'd be a big old number. So the difference of two squares pattern is super helpful. And listen, you're going to use it a lot in Algebra 2.
It'd be 11.
It's going to come up in Algebra 2 a lot. What's that?
It'd be 11,000.
Oh, when you multiply them together? Yeah. And then you have to think of what multiplies. Yeah, question,
What
Adelaide?
happens if there's like more than two terms?
Oh, then it's not this pattern? Yeah. This only works if it's a difference of two perfect squares. This is the only time you get to use that pattern. Is everybody with me? You can't just use this on
How do
anything.
you know if it's not a perfect square?
Oh, well, it helps if you got them memorized, but you can use your calculator, do square root of that number. If it comes out nice, then it's perfect square. If it doesn't come out nice, you're stuck doing something else. Yeah. Okay? All right, so we got difference of two squares. There's another pattern that you can use. And this other pattern is going to be super important in Algebra 2. We may actually do some of it this year. But other pattern, let's do a couple examples, okay? We're going to do a couple examples. Let's do, we're going to factor. Try out a squared plus 6a plus 9. Let's factor it. Let's use the AC method. What's our AC? 9. AC is 9. What two numbers multiply together?
3.
But add to 6. Oh yeah, 3 and 3. Split up the middle term. Factor by grouping. Factor out the common binomial. Oh, okay. They're the same. And when they're the same like this, what's the preferred way to write it is to consolidate it a little bit and write it as a plus 3 squared. Pretty interesting, huh? So it turns out that there's a pattern that you can use. Let's try another one. 4n squared plus 20n plus 25. Well, it kind of looks like we could factor out a monomial first, doesn't it?
4.
But does 4 go into 25?
No.
Does 2 go into 25? Yeah, 25 is kind of messing this up, isn't it? So we're stuck doing the AC method. What's our AC? 100. What two numbers multiply together to make 100, but add together to make 20? 10 and 10. So we get 4n squared plus 10n plus 10n plus 25. Factor by grouping. What can we take out of both of these? 2n. What can we take out of both of these? 5. factor out the common binomial. What's left behind? If they both match, we're supposed to write it as 2n plus 5 squared. Okay, so there's a pattern. We could skip all that work if we wanted to, if only we knew a pattern. A pattern. Anybody think they got it?
Nope.
No? Okay. Well, let's try another one. Let's try another one. Let's see, what is it? Oh, there we go. 9c squared minus 6cd plus d squared. Now remember, that extra variable doesn't really impact your AC, does it? Your AC, you're just going to think of it as 9. What two numbers multiply together to make 9? Negative 3 and negative 3 in order to get negative 6. I like it. Split up the middle term. 9c squared minus 3 what? CD. Minus 3 CD plus d squared. Before you factor by grouping, add the opposite in the middle there. What can you factor out in the front? 3 and a c. Leaving behind 3c minus d. Back here, what do we have to factor out? Negative. What else can we factor? A d. Leaving behind, divide, it'll become positive. The d divides out, 3c minus a d. Do we have common binomials? Yeah. So you get 3c minus d times 3c minus d, which is actually 3c minus d squared. There's a pattern here. Anybody think they got the pattern?
No.
No? Well, I
feel like the first one is still being square rooted.
Oh,
So I
okay.
can't tell what's happening with the other one.
So Titus says that he feels like this first one is still being square rooted. Yeah.
Middle one isn't.
Okay, yeah. What, Lexi?
Divide by the common factor with the ones with the variable.
Well, it turns out, check this out. What's the square root of a squared? What's the square root of 9?
3. The other one doesn't matter.
Here's the thing. The middle number does matter. Okay, it does matter, but it doesn't help you get the answer. Okay?
What?
Take a look. What's the square root of this? 2n. What's the square root of this?
5.
And we're good. Now this one's a little bit different. What's the square root of this? 3c. What's the square root of this?
It's 1.
But notice it had a minus. Okay, so there is a relationship with the middle, and we'll talk about that after lunch. Have a good day. Or have a good lunch. How about that?